Hello kids, here come the notes for sections 2.3 and 2.4. Estimating derivatives is section 2.3 and section 2.4 is differentiability and continuity. So you do need your calculator. We're going to be working with that quite a bit in this section 2.3. So estimating the derivative with a calculator, you need to make sure first of all that you're in radian mode. So grab your calc. All right, here's mine. And I'm going to press home. And then I want to know what the mode is, so I press the mode button next to home. And I'm looking at the fourth one down, and I want to make sure it says radian. If it does not say radian, then go down and highlight it, press the right arrow, and make sure that you then press enter to make sure that it's in the radian mode. You have to press it twice, actually. All right, so that's first and foremost. And then here's what we're going to do. This is not the 83 that the book video used. They use a TI-83. We have the TI-89. And so we're going to do things a little differently. Here's what you need to remember. You need to take, and I'm going to put it up here on the top, y1, you're going to put stuff in y1, your function, and then you're going to graph it. And I'm going to show you how to do all this. You're going to graph it. And then you're going to press 6 for derivative, press enter, and then give it the number, whatever number you're looking for. Because in every one of these problems, they want to know what it is at a specific number. And so that number is going to be the last piece that we put in. And so for every problem we do on the calculator right now, to have the calculator find the derivative, these are the steps that we want to follow. So let me show you how it works. All right, to get to y1, it's the Gatorade button and y equals. And you're going to go up, clear out whatever's in there. And you want to put in this function, sine of the square root of x. So sine is blue, and then the y gets you sine. X, the square root of x, you have a square root button over here at the multiplication sign. I tend to like to put things as exponents because it just is easier to type in. So this would be the same thing as x to the 1/2. So x caret 0.5. And then press enter. And then it pops up in your y1 menu, which is really nice because you can make sure that you typed it in correctly. So make sure it matches what you were trying to do. It is the sine of the square root of x. Here we go. That's my y1 part in what I just wrote. I want to graph it. So Gatorade graph F3. And it says busy. And I say okay. Okay, there's my graph. All right, now I'm going to press 6. I'm sorry, F5. Oh, F5 and then 6. F5. And then 6. F5 gives you your table where you've got values and zeros and maxes and mins. We want derivative 6. So enter. And then it says to you dy over dx, and you're like derivative at, and so I want to know what it is at 2. That's the number in my parentheses. So you type a 2, press enter, and it tells you 0.055. And that's it. There it is. Example 2, you've got ln's. So where is ln in your calculator? I'm going to go back to my y equals, clear out what I had. Oh, clear it out. And I want to put the ln. Well, ln is blue. See the ln over here under home? So it is second, and then the x button gives me an ln. And it's 1 divided by parentheses 5 minus x. Close that up. Nope, it tells me I'm missing a parenthesis. Where am I missing a parenthesis? At the end. Okay. And then again, when I hit enter, see how it types it in there, and I can make sure that I've typed it in correctly. All right, we're going to graph it. Gatorade F3. There it is. F5 and 6 gives me the derivative. And I want to know now what the derivative is at 1.3. So typed in a 1.3, and it tells me it's 0.27027. And so from the lesson video, that's exactly what you were trying to do. Now he again did it on a TI-83. We're using an 89. There is more than one way to do a derivative. It's also available through the home menu. If I go to the home menu and hit F3, you can see the very first thing is differentiate. That's a way to find a derivative as well. It's a little bit more cumbersome, and I think I tend to like the graphing approach better. So there you go. All right, so next question says, Write the equation of a tangent line. Well, the equation of a tangent line, you need a slope and you need a point. For any type of line, you need a slope and a point. Slope is the derivative. So the question is, what's the derivative of this function, square root of x over x cubed plus 1, when x is 1? And so you do the same thing. You type it into your calculator, just like we've been doing. You do your graph, your F5, 6, enter, and this time you're putting in a number of 1. When you do that, you get negative 0.177. But you also need a point. And so that point comes from what the y value would be if you plug a 1 in. So if you've got 1 over 1 cubed plus 1, you've got 1 over 2. You need the square root of 1/2. And that comes out to be 0.707. And then you put it in your point slope formula. So y minus y1 equals m times x minus x1. And there's your equation of a tangent line. I'll go through one of those in the example problems in just a minute. Okay, so then you've got a table and it says they change things up. The function must be differentiable. In other words, it has to have a derivative, which means it's continuous and smooth in order to estimate the derivative. This just means that the graph is continuous and smooth. They want us to estimate, and again, it's an estimation, not an exact value, from the table of values. These are hours and these are miles. They want us to know what f prime of 3 is. So what is the derivative at 3? Well, 3 is not on your chart. But if I did have 3, it would be right here. It would be between 2 and 4. And so what you're going to do is use the number to the right and use the number to the left in order to estimate what the actual derivative is at 3. So I find f of 4 minus f of 2 over 4 minus 2 because they are table values that I can readily look at. That gives you 10 minus 3 over 4 minus 2. Or 7 over 2, and in the top are my f of x things, that's miles, and in the bottom are my x values, that's the hours, so it's miles per hour. Units are going to be very important in these problems. And then the last example he did on the video, same idea. Use this table to estimate the derivative of 100. Well, 100 is not on your table, but if it were, it would be right here. You're going to go a little to the right, a little to the left. F of 120 minus f of 80 over 120 minus 80 gives me this setup, or negative 200 over 40, negative 5 gallons per second per second. That's kind of weird. Normally we write it as gallons per second squared. You might have seen that in physics, and that came up in class today. Some of you remember that notation from a physics situation. The fact that it's negative, if I'm looking at that, I can see that my y values are decreasing. They're getting smaller as I go along. And so that should make sense that this is a negative value. All right, here comes some examples that go with the section. First one is, first set, I have estimate the derivative at the given point using a calculator. Okay, so the first one we did was number 1. Let me go back and get into my y equals. And I want to clear out the function I have in there already. So right now I've got still that ln guy in there. So I'm going to go up and clear him. And in my y1 I want to put in x. Sometimes your calculator likes to have a times sign. So x times the square root of 2 minus x. I'm going to put 2 minus x, and I'm going to raise it to the 1/2 power, to the 0.5 power. Same thing as the square root. And then I'm going through my steps, right? I got it in there. Now I'm going to graph it. So Gatorade F3. And there it is. And then I'm going to find the derivative. So F5, 6. Enter. And it says, where do you want the derivative? And I say at negative 10, because that's the number in the parentheses. And so I get an answer that's 4.907. We'll take it 3 decimal places. Number 2 was another one that was requested, secant of 5x. And I'm looking at the calculator and I do not have a secant button. So I have 2 options. Option number 1 is to take this thing and think of secant and think of what it's reciprocal with from back in pre-calc. And I know that secant is reciprocal with cosine. So this would be the same thing as if I had the cosine of 5x but 1 over that, the reciprocal of that. So I can literally put that in the calculator and work my way through that. The other option, I'm going to show you this option, is to use the alpha buttons and literally type in SEC. And if I do that, the calculator automatically understands. Now you can find secant in a couple other menus on the calculator. One menu that you can find that at is in the math menu, and the other place that's on this blue and then 5 gives you the math menu. It's also in your catalog if you wanted to find it through the catalog. For me, it's easier just to type it in. So I'm going to F1, I'm clearing out what I had, and I'm going to alpha. So alpha button is next to the Gatorade button. Alpha A is the equal sign. Oh, I want S, my bad. S. Alpha 3. Alpha 3. There it is. I want an E. Give me an E. That's alpha division sign. And I want a C. C is alpha and the right parenthesis. And then I need parentheses X. Oh, but it's 5X, right? 5X. There it is. So you can literally alpha type that in. I'm going to graph it. Remember the secant graph, a bunch of happy and sad parabolas. There it is. There's a lot of them. Okie doke. It's done. So now I'm going to F5, 6 to get to derivative. And I want to know what's the derivative when x is 2. And it tells me negative 3.864. If I were rounding. There it is. Number 7 is another one that came up. X divided by the cosine of x. They want us to, this function models the height of birds in meters where t is in seconds. So how's the height of the bird changing over time? And so find the derivative at 2. All right, so I'm going back to my y1, and I'm going to put in x divided by cosine of x. There it is. I'm going to graph it. Kind of cool looking. And then I'm going to find the derivative. So I'm doing F5, 6, and I want to know what it is. Again, the number happens to be 2. And I get 8.098. So this one is 8.098. Now this one gave me some specifics, and so this one I need to include units on. I haven't had to do that up until this point because nobody had units, but I do now. So this one is where it measures the height of the bird in meters. That would be my first thing. And where its t is seconds. So meters per second. Okay, question came up. We're not going to actually do this problem, but the question came up about number 8. And see how it's the sine squared of t? That's the same thing as saying the sine of t squared. They're one and the same. So however you want to, and I think your calculator takes it both ways. I would tend to go this way with it. Seems to be a little safer. All right, so that was 8. Number 11, here they changed the directions. For each function, write the equation of the tangent line at the given point. Well, it starts out doing the exact same thing that we just were doing, because in order to find the equation of any line, tangent line specific for us, we need to know a slope and we need to know a point. Well, the slope is the same thing as the derivative. So I want to know what's the derivative at 2. Well, isn't that the same thing we just were doing up above, right? So I'm going to come over here to my calculator and I'm going to put in my y1 of cosine of the tangent of x. So go into your y1, put it back over here so you can see it. If I go into my y1, what did I say? Cosine of the tangent of x. Cosine, and then it opens up parentheses and I'm putting in tangent, and then I'm putting in an x, and I've got a double parenthesis, close that. And there it is, cosine of the tangent of x. Same thing, I want to know what the slope is. Do the same problems you've been doing. So I'm going to graph it. Busy. Kind of cool looking graph. And then I'm going to find the derivative, f5, 6. I want to know what the derivative is at 2. And it tells me 4.719. So my slope is 4.719. Totally gotten off the calculator. Is that good English or what? But then I need a point, and guess what? The point's going to be really easy to get because you know the x value is 2. If I go back and let the calculator do the work for me, I want to get to the table over here. So I'm hitting Gatorade and table, and I want to know what is it when x is 2, what's the y? So I type a 2 in, and it gives me out a negative 0.576. Well, that's this corresponding y, negative 0.576. That comes from the table. Just go right to the table. It will do the work right for you. And then I have all the info I need. I'm using point slope formula. I've got y minus my y coordinate makes this plus 0.576 equals my slope of 4.719 times x minus 2. There's the equation of the tangent line. So again, they're done quite similarly to the first 9 questions. All right, then the last couple questions, the last one we're going to look at, the last kind of example, is number 18. You can see these are all the same type of questions. You've got a table, you got to figure out a derivative. Well, it's the same thing as the slope formula. The one that we picked was number 18. If I'm thinking slope, I'm thinking derivative. I'll put it over here. The derivative is the slope, which is f of b minus f of a over b minus a. The general formula we've got going on. So for number 18, I want to know what's going on at 20. 20 is not on your chart, but 20, if it were on your chart, would be right about here. And so I'm going to set it up. I'm going to take f of 30 to the right, f of minus f of 10 to the left, over 30 minus 10. And so I go through and I calculate. I can see from the chart what these numbers are. I have 790 minus 1005 over 30 minus 10 is 20. And so I go to my handy dandy calculator, I do out my calculations here, and I get negative 10.75. This one has units, gallons per second per second. That's going to be gallons per second squared. Does it make sense that it's negative? Yeah, because I'm decreasing, getting smaller. All right, 82.5. 82.5 is not on my chart, but it would be right about here if it were. I'm going to go a little to the right, a little to the left. F of 100 minus f of 65. Oh, by the way, these are W's, aren't they? I should have W's, not F's. You got the idea. All right, so here's my story. 100 is 209. 65 is 434. 100 minus 65 is 35. I go to my handy dandy calculator. I calculate that out. Negative 6.4285. Units are gallons per second per second. Gallons per second squared. Every single one of these chart questions are done the same way. They get a little cumbersome because there's a lot of them. And you're doing the same thing over and over. But you can handle it. You got it. All right, last ones that we're going to look at. These came up as questions in class on the test preps. Number 20 we're going to do out, but number 21 we are going to just kind of talk about. I'm going to give you a clue as to what on earth they are asking you to do. So here's 20. Again, these are worded like AP questions. They're a little bit tricky to understand. What the heck are you asking me to do? Here goes. Let f and g be the functions defined by f of x is this guy, g of x is this guy. Let h be the vertical distance between the graphs. Well, vertical distance between the graphs would be like this. How far apart are they? let h be that. This is h. Between 0 and 2. Find the rate at which h changes. In other words, you want to find h prime, how h is changing with respect to x when x is 1.5. They're asking you to figure this out. What's h prime of 1.5? Well, it's the vertical distance between the two graphs. If I'm the vertical distance and I'm up here at close to 4, we'll just for rough purposes, close to 4, and I'm down here at 2.5 or 1.5, whatever that might be. In order to figure out that distance, what would you do with those two values? You would take them and you would subtract them. And so that's the same thing you're going to do with this. In order to get here, you need to figure out what top guy, f prime of 1.5 is, and you want to subtract away what g prime of 1.5 is. In order to figure out that distance between those, you need to subtract the values. All right, so here's what you got to do. You're going to figure out what this is, f prime of 1.5. And the way you're going to do that is like we did those very first questions. You're going to go to your handy dandy calculator, go to F1, and you're going to put in that equation, negative 1/2, negative 0.5 x cubed plus 3x plus 1. Put it in there, you're going to graph it. And then you're going to find the derivative, f(5,6), and you want to know what it is at 1.5. And you get negative 0.375. If I went too fast, you can pause me. And I'm going to do the same thing with my g prime. Now, how do you get e? That came up as well in class today. If I go into my y equals, cancel out what I have, and I look at e is where the x is. So you see how the e is a green kind of thing? It's your Gatorade color. So it's Gatorade, and then your x button gives you e to the x, and we want x divided by 2. X divided by 2. So I'm taking x divided by 2 as my power. There it is. Looks good. I'm going to graph it. And then I'm going to find the derivative at 1.5. And I get 1.0585. 1.0585. When I subtract those two values, there's my answer, negative 1.4335. Okay. Then I gave some direction on 21. I didn't quite finish it, but I gave you some direction because this one, again, the wording's a bit confusing on what they're asking you to do. So the graph of this function crosses the x-axis at one point. What's the slope of the graph at this point? Well, the problem's asking you to figure out where, first of all, where does it cross the x-axis? Where's your x-intercept? Where's your 0? Right? If it crosses the x-axis, you want to know what the 0 is. Well, your handy-dandy calculator can do that for you, just like the old 83s could. So I'm going to put this in my y equals 3 minus e to the 5x. Here it is. And I'm going to this time go to, I guess I can graph it first. Take a peek at what it looks like. Cool, there it is. I want to know what the 0 is. You could solve this in your solve algebra menu back in the old home thing, but since we've got the graph going on, we're here. I'm going to go to F5 and see how I have my whole menu. This is where our derivative thing is. But other than that, I can also find the 0, number 2. So I'm going to have it do that. I'm going to press 2. And it asks me for a lower bound and an upper bound. In other words, it wants to point to the left of where that 0 is and to the right of where that 0 is. Back on the 83s, we would find that blink and blinker and make the blink and blinker go to the left, and we'd press enter, and then we'd make the blink and blinker go to the right, and we'd press enter. But you can just type in values. If I'm looking at this grid, I can see it crosses through the x-axis somewhere between 0 and 1. So that's what I'm going to put in. My lower bound 0, my upper bound is 1. And it says, okay. There it is, a 0 at 0.2197. So that 0 happens when x equals 0.2197. Well, then it's asking for what's the slope, what's my derivative at this point. So I want to know what is f prime of 0.2197. You already have the function in your y1, so all you need to do is go in and find the derivative at that point. Pretty easy from there. Okay? All right, that takes us through section 2.3, and we're going to real quick do 2.4, because 2.4 is easy peasy lemon squeezy. Here it is. All right, let me switch up my papers. Two-4, differentiability and continuity. So if a graph of a function is shown below, write down the equation on line number 1. So if I look at this, it looks like a straight line. I'm thinking y equals mx plus b. Here it goes. Yeah, it looks like a slope of 2, rise over run, and it has a y-intercept of 1. So put that together, I get 2x plus 1, and I'm pretty confident that that's the equation of that graph. But wait. Second thing he did on the video, and again these are from the video, so I'm just going to talk pretty quick through it. He changed the scale. He made this 0.001, 0.002, 0.003, and then your y-intercept's at 0.001. Your slope is still looking like a 2, so there you go. You've got 2x plus 0.001 if you change the scale. And then he showed this graph of the sine of 2x plus 0.001. Well, that kind of looks like a sine graph. Remember the sine graph? So it would look kind of like this. However, then he zoomed in, real zoomed in this highlighted box I have here. And if I zoom in just on that part of the graph, it looks like a straight line. And it's all about the zooming of this. And so what they call that is locally linear. That in that area, it looks like a straight line. It's called locally linear. And so if I zoomed in enough, it makes this sine graph that we know are a bunch of hills and valleys actually look like a line. So it's locally linear. So we have to be careful in calculus when we're looking at these things, because it could be that you're really looking at a graph of 2x plus 1, but it could be that you're so zoomed in that you're really looking at a graph that's something totally different. All right, it's called locally linear again. So differentiability means that you're able to take a derivative. The derivative exists for each point in the domain. The graph must be smooth, a smooth line or curve for the derivative to exist. In other words, the graph looks like a line if you zoom in. Locally linear, we just were talking about that. So there's 3 things that fail to have a derivative. First thing is when there's discontinuities. You can either have a hole or a jump. We've seen those before. You can have a corner or a cusp. Corner like an absolute value graph, or a cusp like this graph. This is like x to the 2/3 power. Or you could have a vertical tangent line. Now think of tangent lines. If I were my pen and I was a tangent line over here, I'd kind of be tangent lining like this, and then I'd curve around and my tangent line would get more steep until I finally get to this place where I get a vertical tangent line. And think about the slope of a vertical line. Well, the slope of a vertical line is undefined. So therefore you can't have a value there. It's an undefined slope. You have no derivative, right? Slope is derivative. So if you have a vertical tangent line, and actually this is a place where it changes concavity, right? It's concave going this way. We're going to talk about that eventually. Has to do with the second derivative. And then it's concave this way going the other way. So when it changes that, it turns out to be a vertical tangent line and your slope is undefined. So the first question he did with you is, okay, here's a graph. Look at it, tell me where it's not continuous and tell me where it's not differentiable, and or. All right, I'm skating along, read it from left to right. First place I come to is here. I have an open circle. It's not continuous. I have to pick up my pen. But then I keep going and I have a pointy place. Any pointy place is going to be a corner or a cusp. Can't have pointy places, so it's not differentiable at -2. Keep going, happy, happy, happy. There's a point there, so what? Keep going. Pointy place at 2, not differentiable. Keep going. Got a jumper, discontinuity at 4, and there you go. So the graphs for these are pretty easy. Then there's these true-false questions, and this comes up an awful lot as point of discussion within calculus. If it's differentiable, does it mean it's continuous? And if it's continuous, does it mean it's differentiable? Kind of like it came up to, remember the squares, a square, a rectangle, and a rectangle, a square, same concept kind of thing. So if it's differentiable, does it mean it's continuous? If it has a derivative, does it mean it's continuous? And the answer is yes. And remember, it has to be smooth, and it has to be continuous. But if it's continuous, does it mean that it's differentiable? And the answer is no. Just because it's continuous doesn't mean it has a derivative. And the one that keeps me straight in my head is I think about the absolute value graph. Because if I draw that, it does not have a derivative here, but it is continuous. So continuous, but not differentiable. You can be continuous, but it doesn't mean that you're differentiable. And again, the way I keep that straight in my head is by thinking about the absolute value graph. All right, so let's try a couple problems. I'm going to go with number 3. We actually didn't have time in class to be able to do some of these. These were really simple, though. I don't think that you really need a whole lot of help. But nonetheless, find the x values where the function is not continuous. Find the x value where the function is continuous but not differentiable. All right, read the graph. First thing I come to is at x equals -5. That's where it's not continuous because there's a hole. So I have x equals -5. Keep going. Oh, pointy place at -3. That means there's no derivative. X equals -3. Keep going. This is actually a pointy place too. You have to make a sharp turn. So at 0, it is also not going to have a derivative. Keep going. Got a jumper. That's a discontinuity at 2. There it is. And then it's happy the rest of the graph. That's all you're doing for those. How about that? When is calculus ever that easy, right? And then you've got the test prep questions. You're going to have to go through these one step by one step. I'll kind of show you what I mean. Like a number 6. I'm not going to do the whole problem with you, but think about what this is. This is an absolute value graph, and it's got an x minus 4. How does that shift the graph? All of those things we learned back in the day should come into play with this. This guy is an x minus 4, so it is right 4. Absolute value graph. And then take each thing. Is it continuous there at 4? Is it differentiable at 4? Does it have an absolute minimum, lowest point overall at 4? And then you're going to figure out yes or no to these, and then figure out which one of the answers goes with it. So all of those test prep questions are kind of done that way, where you're thinking of what the graph looks like and then answering each piece individually, and then deciding which ones are true or false. All right, that's it. You are working on numbers 1 through 7 from this section, and I think it was 1 to 22 from section 2-3, and when we get together again, we will talk answers to that and move on to 2-5. 2-5 is the best section of calculus ever, so get ready to have a really good day in calculus again. A couple easy sections all in a row. Have a good day. See ya.